All right, so we're going to look at solving linear equations that involve fractions. So notice that in this linear equation, you have this fraction, 4/3. You have this fraction, and you're subtracting this fraction, which is 3x minus 5 divided by 2. And on the right-hand side, you have this fraction, 2 minus 3x divided by 4. And you're adding that to this fraction, which is x plus 1 divided by 3. So in solving linear equations that involve fractions, like you see here, where the denominators here are not 1, this denominator is 3, this denominator is 2, this denominator is 4, and this denominator is 3. The best way to do that is to go ahead and clear the fractions. So meaning that you want to get these denominators to be factors of 1. So you want 1 in those denominators. So that's what we mean by clearing the fractions. And to do that, you're going to multiply both sides by the least common denominator. So if you look at all of those fractions here, 3, 2, 4, and 3, the least common denominator, the smallest number that those four numbers, 3, 2, 4, and 3, will go into is 12. So you always want to use the least. So you want to use the least common denominator. Don't use just any common denominator like 24. Those numbers go into 24 evenly, or divide into 24 evenly. But if you use the least, it makes things so much easier for you. All right, once you find the least common denominator, here's the next process. So I want you to notice that on the left-hand side, there are two fractions. And on the right-hand side, there are two fractions as well. So meaning there's more than one fraction. Whenever a side of an equation has more than one fraction, you need to put that in parentheses. So meaning this, you're going to write this as 4/3 minus 3x minus 5 divided by 2, notice in parentheses, equals, same thing here, 2 minus 3x divided by 4 plus x plus 1 divided by 3. All right, now, this is where we're going to use the LCD. So one of our properties when solving equations is that what you do to one side, you have to do to the other. So if I'm going to multiply the left-hand side by 12 by the least common denominator, I also have to do it to the right-hand side. So that's your next step. So the next step was to multiply both sides by the least common denominator. And now we're going to use the distributive property. So I will need to get rid of those parentheses now. So I introduced it. Now I've got to get rid of it. So we're going to multiply every fraction that's inside those parentheses by the least common denominator, by this number out here, because this means 12 times. So 12 times all of these fractions that's in the denominator. That's in this parentheses. So you can do the same thing here. You're going to use the distributive property. So when you write this, this is what it looks like now. So you're going to say 12 times that first fraction, just like this, minus 12 times the second fraction, just like this, equals, and then the same thing here, 12 times the first fraction, and then plus 12 times the second fraction. All right, so that's what we have. So basically, you're taking each of those terms, each of those fractions, and you're multiplying it by the LCD. So remember, the whole purpose of multiplying both sides by the LCD is to clear those fractions, meaning you want factors of 1s in those denominators, and now you do. So, because look, when I reduce this now, 3 into 3 is 1, 3 into 12 is 4. 2 into 2 is 1, 2 into 12 is 6. 4 into 4 is 1, 4 into 12 is 3. 3 into 3 is 1, 3 into 12 is 4. All right, so notice I have factors of 1s in those denominators. So my next step, you're going to notice that I'm not going to have any fractions anymore. So now I'm getting to the point where I can easily solve for the variable. I can determine very easily what the solution is. What value of x makes the left-hand side equal to the right-hand side. All right, so now what we're going to do is we're going to simplify each of those products. 4 times 4 is 16. Subtract. All right, now you got to be careful here because all of these terms that's in the numerator have to be multiplied by 6. So here's what you need to do. just to be on the safe side, you need to say minus 6 times, in parentheses, 3x minus 5. So what you may want to have done first is to possibly, right here, put that in parentheses right away, just like this. So every term inside that's in the numerator has to be multiplied by the 6. Every term that's inside the numerator has to be multiplied by 3. Every term that's in that numerator has to be multiplied by 4. Now you may say, well, why didn't you put that in parentheses? Because that's just one factor, one term. 4 times 4 is 16. That was easy. Over here you have more than one term. You have two terms here, 3x and a negative 5. 2 and a negative 3x. X and a positive 1. All right? So just remember that as you go through this process, you got to remember some things that you've learned in the past. All right, so then we get equal, and then 3 times every term that's in this numerator, because notice this is a 1, right? So 2 minus 3x divided by 1 is 2 minus 3x. Plus 4 times x plus 1 divided by 1 is x plus 1. All right, so notice I have parentheses again, so now we have to use distributive property. All right, now be careful because some students make the mistake and say 16 minus 6 is 10. You cannot do that. Remember, order of operations says I have to multiply before I subtract. So you have to distribute that negative 6. Same thing here, distribute 3, and then distribute the 4. All right, so be careful around this area. That's an easy mistake that some students make. All right, so we get 16. Negative 6 times 3x is a negative 18x. Negative 6 times a negative 5 is a positive 30. Equal 3 times 2x is 6. 3 times 2 is 6. And then subtract 3 times 3x is 9x. Plus, and then distribute here. 4 times x is 4x. And then 4 times 1 is 4. All right, at this point, you're going to combine like terms. So on the left side, the only terms I can combine that are like terms are these constants, 16 and a positive 30. So combining those, I get a negative 18x plus 46 equal. On this side, let's go ahead and combine the variables first, the variable terms. A negative 9x, see, that's a negative 9x. So if you combine those two, you got to remember this is a negative 9x. So a negative 9x and a positive 4x is a, make sure I did this correct. All right. So negative 9x and a positive 4x is a negative 5x. 6 and 4, now I can combine these two, right? These constants. So 6 and 4 is 10. So I get plus 10. All right, so that's where I'm at. Okay, now, so I combine like terms on the left, I combine like terms on the right. All right, so the next thing you want to do is to solve this linear equation. And notice I no longer have any fractions, right? So at this point, I cleared my fractions. So now it makes things a lot easier for us. So what we're going to do is I'm going to bring all the variables to the left-hand side and all the constants to the right-hand side. So here, that's a negative 5x. So to get rid of that term, in other words, to bring it to the other side, I've got to use one of my properties of equality. So the opposite of a negative 5x is a positive 5x. I'm going to add 5x to both sides. Notice what I'm doing. What you do to one side, you do to the other. Okay, so once on the right, once on the left. And notice I'm adding 5x because that's the only way I can get a 0 here. A negative 5x and a positive 5x is 0. Those are opposites. So if I add 5x to the right, I have to add 5x to the left. It's like keeping a balance here. A negative 18x and a positive 5x is a negative 13x, right? Plus 46 equal, and then 10. 0 plus 10 is 10. All right, now let's go ahead and get rid of this 46. So right now I'm adding 46. The opposite is to subtract 46. So I'm going to subtract 46 from both sides. And when I do that, combining like terms, those are opposites. 46 and a negative 46 is 0. So I get negative 13x plus 0 is a negative 13x equal, and a positive 10 and a negative 46 is going to be a negative 36. All right, and then divide. Now notice, remember, you got to get x by itself, right? So we're now multiplying x by negative 13. The coefficient of x is negative 13. Let me go ahead and rewrite this over. And so the opposite is to divide both sides by that coefficient. So the opposite of multiplication is division. Notice negative 13 is what I divided by because that's that coefficient here. And negative 13 divided by negative 13 when I reduce is 1. 1 times x is x. And then negative 36 divided by negative 13. First of all, a negative divided by a negative is a positive, right? All right, so far this becomes positive 36 divided by 13. Okay, now you can notice that 36 and 13, there are no common factors. No common factors. So, and remember, 13 is prime, right? And 13 does not go into 36 evenly, so you can leave your answer as this improper fraction, 36 divided by 13. Or if you want to write this as a mixed number, 13 divided into 36. 13 divided into 36, 13 will go into 36 2 times. 2 times 13 is 26. Subtract, you get 10. So it's 2 and 10 thirteenths. So 2 and 10 thirteenths. All right? And so that's the solution. So the value of x that makes the left-hand side equal to the right-hand side is when x is 2 and 10 thirteenths. All right, so that was number 1. All right, let's look at number 2. All right, so this is number 2. So we want to solve this linear equation. Notice that this equation has fractions. So you have this fraction, 3x minus 7 divided by 6, and you're subtracting this fraction, 3/4, and that's going to equal this fraction, which is x plus 8 divided by 5. So you're going to find the value of x that will make the left-hand side equal to the right-hand side. And so to do that, there's no way you can look at this and say what the answer is, what the solution is, so you have to do this solving process. So since I do have fractions, we're going to go ahead and clear the fractions, and so we got to find the least common denominator. So the smallest number that 6, 4, and 5 will divide into evenly. All right, so it turns out that the least common denominator of 6, 4, and 5 is 60. So 6 goes into 60 10 times, and you can always check and see if this number is divisible by all of these. So you just say 60 divided by 6 is an integer, right? It's 10. 60 divided by 4, so when you say 60 divided by 4, you get 15. And then 60 divided by 5, you're going to get 12. All right, so each of those numbers will go into 60 evenly, and 60 is the least common denominator. All right, so now once you find the least common denominator, remember you want to multiply both sides by that least common denominator to get those denominators to be 1s. Now, since the left-hand side has 2 fractions, we'll go ahead and put that in parentheses. So I'm going to get 3x minus 7 divided by 6 minus 3/4, and we put it in bracket, equal. Now, that's just one fraction right here, so I'm just going to say x plus 8 divided by 5 without any parentheses, since that's just one fraction. All right, so now once you get to that point, the next step is to multiply both sides by that least common denominator. So notice I said multiplication here. So 60 times this, the left-hand side, equals 60 times the right-hand side. Now, since I do have brackets here, so remember the next step is to go ahead and get rid of these brackets, and that is to use the distributive property. And then notice that all I need to do here is reduce at this point. But let's go ahead and distribute first. So I get 60 times 3x minus 7 divided by 6, subtract 60 times 3/4 equals, I'm just going to go ahead and rewrite this over, 60 times x plus 8 divided by 5. All right, now the next step is to get these factors, or these denominators, to be factors of 1s. So if you're doing this correctly, when you reduce, 6 and a 6 is 1. 6 and a 60 is 10. Okay? 4 into 4 is 1. 60 divided, use your calculator if you have to. So use your calculator if you have to. 60, let me get the glare out of the way. All right. So 60 divided by 4 is 15. So I get 15 here. And then over here, 5 divided by 5 is 1. And then 60 divided by 5 is 12. Okay? All right, so that's what I have. Let me make sure. All right, so I was just making sure that see, when you transpose, when you rewrite things, sometimes it's easy to write different numbers than what you should have. So I'm just checking, and everything looks fine. All right, now remember at this point, so this 10 here, and also notice you have factors of 1s in the denominator. That's what you want. You want to clear those fractions. But I want you to remember, see this numerator here, there are two terms, 3x and a negative 7. All of that has to be multiplied by this 10. Now that's just one term, so I'm not going to put that in parentheses. Over here, though, I have more than one term, so all of those terms has to be multiplied by 12. So just keep that in mind. So it does help at this point to put those numerators in parentheses. All right, so now we're going to say 10 times 3x minus 7, because 3x minus 7 divided by 1 is 3x minus 7, minus 15 times 3, right, equals 12 times, in parentheses, x plus 8. All right, now notice no fractions, so that's an easy linear equation to solve. I just have to get rid of the parentheses using distributive property in both cases here. And so I get 10 times 3x is 30x, 10 subtract, and then 10 times 7 is going to be 70. Subtract, and then 15 times 3 is 45. Equal on this side, 12 times x is 12x, and then 12 times 8 is going to be 96. All right, now on the right-hand side, there are no like terms, but on the left-hand side, there are. These are constants. So a negative 7, now you can think of this as a negative 7 and negative 45. All right, so when you do that, you're going to say negative 70. You put that here. So you're going to say negative 70 plus a negative 45 equals a negative 115. So this becomes 30x minus 115 equal, and then 12x plus 96. All right, now, when solving a linear equation, you want to bring all the variables to one side, constants to the other. It does not matter whether you bring the variables to the left or the variables to the right. I'm going to just go ahead and bring the variables to the left. So I need to bring this 12x term to the other side. So since it's a positive 12x, the coefficient 12 is positive, I'm going to go ahead and do the opposite, which is to subtract 12x. Notice I'm aligning my like terms. 30x and a negative 12x is 18x minus 115 equal, and then these terms here, 12x and a negative 12x, those are opposites, you get 0, and then 0 plus 96 is 96. All right, so to get the variable, see, if you look at what you have here, this is the only term with the variable, so you want to bring this constant term to the other side. So right now I'm subtracting 115. The opposite of subtracting 115 is to add 115 to both sides. Notice what you do to one side, you do to the other. Combining like terms, these are opposites, so that has to be 0. Negative 115 and a positive 115 is 0. So I get 18x equal 96 plus 115, use your calculator, 96 plus 115 equals 211. And then divide both sides by 18. Let me go ahead and rewrite this over. We get 18x equal to 11. So to solve for x, get x by itself. Right now I'm multiplying x by 18, which is a coefficient, and the opposite of multiplication is division. So 18 divided by 18 is 1. 1 times x is x. Reduce if you can, but you'll see that 211 divided by 18, the common factor is 1. There are no other common factors. So you can leave your answer like this as an improper fraction. Or if you want to, you can write as a mixed number. So 18 divided into 211. So 18 to 21 is 1. 1 times 18 is 18. Subtract. 21 minus 18 is 3. Bring down the 1. And then 18 into 31 is 1. 1 times 18 is 18. And then 31 minus 18 is going to be 13. And so we get 11 and 13 eighteenths. So 11 and 13 eighteenths as a mixed number. And so that's it. That's the solution. So that's the number. Either one of these, those are equivalent. This is a mixed, this is the improper fraction. This is a mixed number. But that's the solution to the original equation. So that's the solution. That's the number that when we substitute the value of x, the left-hand side will equal the right-hand side. All right, so that is the two examples rather on solving linear equations that involve fractions.